Hello everyone, this is Abhishek Mahanti, and in this video we are going to solve this question, and this question is from the chapter electric potential and capacitance. So let's get started. So students, the question is four capacitors C1, C2, C3 and C4 are connected to a battery of 12 volt as shown in the figure. Find the potential difference between the points A and B. So look at this diagram here. We have four capacitors, C1 equal to 8 microfarad, C2 equal to 4 microfarad, C3 equal to 3 microfarad, and C4 equal to 6 microfarad. So in this diagram, C1 and C2 are connected in series. Similarly, C3 and C4 are connected in series, and the equivalent of C1 and C2 is in parallel with the equivalent of C3 and C4. And here we have a point A and here we have a point B. We have to calculate the potential difference between the points A and B, and you can see that this entire combination is connected to this battery of potential difference 12 volt. So you can see that the positive of the battery is connected to this point. Let us say this point is P and this point is Q. So the point P is connected to the positive of the battery and point Q is connected to the negative of the battery. It means the potential difference between point P and point Q will be 12 volt. So if I assume that the potential of P is 12 volt, then the potential of Q will be 0 volt because the potential difference is 12 volt. So 12 volt minus 0 will be 12 volt. Or you can take the potential of point P to be 13 volt. The potential of Q will be 1 volt. So 13 minus 1 will be 12. But for our mathematical simplicity or for our convenience, let us take the potential of point P to be 12 volt and the potential of point Q to be 0 volt. And similarly, let us assume that VA is the potential of the point A and VB is the potential of the point B. So now we are going to find what is the value of VA minus VB, the potential difference between these 2 points. So here we will use the property of the combination of capacitors. We know that in series combination, the same charge appears across all the capacitors. So in the diagram, C1 and C2 are connected in series. So I can write that charge on C1 will be exactly equal to the charge on C2 because C1 and C2 are connected in series. Now how can we calculate the charge on a capacitor? We know that this formula Q equal to C into V. So Q means the charge on the capacitor, C is the capacitance of the capacitor, and V is the potential difference between the two plates of the capacitor. So first I will write the value or the expression for the charge on C1, and the value will be how much? The value will be capacitance of C1, which is 8 microfarad. So 8 microfarad means 8 into 10 to the power minus 6 farad into the potential difference across this C1. So you can see that the left plate of C1 is connected to the point P, means the left plate is at potential 12 volt and the right plate is connected to the point A. It means the potential of the right plate will be VA. So the potential difference will be how much? It will be 12 minus VA. So this is the charge on the capacitor C1, and that will be equal to the charge on capacitor C2. So what is the capacitance of C2? That is 4 microfarad. So write 4 into 10 to the power minus 6 farad into the potential difference between the two plates of C2. So again you can see that the left plate of C2 is connected to VA, the right plate is connected to the 0 volt. So the potential difference between the two plates of C2 will be VA minus 0. That implies I can write that 8 into 10 to the power minus 6 into 12 minus VA is equal to 4 into 10 to the power minus 6 into VA. So in the next step, you can just take this value and divide on this side. So 8 into 10 to the power minus 6 divided by 4 into 10 to the power minus 6 will be 2. So I can write that 2 into 12 minus VA is equal to VA. That implies 24 minus 2 VA is equal to VA. That implies 24 equal to 3 VA. That implies VA equal to 24 by 3, which will be equal to 8 volt. So we got that the potential of the point A is 8 volt. Now in the same way we are going to find what is the potential of the point B, and for that we have to consider the capacitor C3 and C4, and we know that the charge on C3 is equal to the charge on C4. So again I'll write that charge on C3 is equal to the charge on C4. So that implies what is the charge on C3? I have to write the capacitance, which is 3 into 10 to the power minus 6 farad, into potential difference across C3, which is 12 minus VB, that is equal to charge on C4, and we know that the capacitance of C4 is 6 microfarad, which is 6 into 10 to the power minus 6 farad, and the potential difference will be VB minus 0. That implies 3 into 10 to the power minus 6 into 12 minus VB is equal to 6 into 10 to the power minus 6 into VB. So now I can divide this 3 into 10 to the power minus 6 on the right side. So I will get 12 minus VB is equal to 2 into VB, because 6 into 10 to the power minus 6 divided by 3 into 10 to the power minus 6 will be 2. That implies 12 equal to 2 VB plus VB, means it will be 3 VB. That implies VB equal to 12 by 3, which is 4 volt. So you got that the potential of the point B is equal to how much? It is 4 volt. So potential of A is 8 volt, potential of B is 4 volt. So finally I can write that VA minus VB is equal to 8 volt minus 4 volt, that is equal to 4 volt. It means the potential difference between A and B is 4 volt. So students, in this way you can solve this question, and I hope that all of you have understood this procedure and the concept behind this question. If you have any doubt, then you can ask me in the comment section. I'll again meet you in the next class. Till then, have a nice day and bye bye.